This part of the lesson is going to take the two answers from the quadratic formula, which are negative b minus b squared, square root of b squared minus 4ac over 2a, and negative b plus the square root of b squared minus 4ac over 2a. We are going to add them together and look for a reason behind one of our formulas. So I'm going to write them here. We're going to find the sum of these two roots. And this seems kind of crazy to add these two together, but we will see that it gets much simpler once we add them. So they already have a common denominator. Basically, when I add, the denominators have to be the same. I notice that when I add my numerators, basically we keep the common denominator, which is 2a, and we're adding the numerators, that these two sections will just completely cancel out because they're opposite signs. Negative b, or negative 1b, plus negative 1b is negative 2b, and my 2's cancel, right? When I look at this fraction, right, we can cancel the 2's, and I have that the sum of the roots is negative b over a. So I don't know the roots, but if I added them together, that simple formula is what that would be equal to. Now to find the average of the two roots, basically we just divide by 2. So if I have negative b over a, right, that's adding the two roots together. One root plus another root. When I add two things together to find the average, I divide by 2. Right? If you have two tests, add them together, divide by 2. So if I divide this by 2, now this is going to take a little fraction work. Basically, when we have division with fractions, I keep the first fraction, it's called keep, change, flip, change it to multiplication, and I'm going to flip this number. I just made it a fraction, 2 over 1, so it's going to become 1/2. When we multiply across, that gives me negative b over 2a. So the question is, where have we seen this average formula before? And why does this formula make sense for the average of the roots? So hopefully you noticed from earlier in the unit that this is the formula for the axis of symmetry. So this is the axis of symmetry. And if we draw a little graph, you can draw any quadratic that crosses the x-axis anywhere you want. So if these are my two roots, the axis of symmetry is always the average of them, right? It's directly in the middle, and that's part of its symmetry, right? So basically it makes sense because the axis of symmetry is directly between the roots. So as we go through the course, we try to find as many ways as algebraic formulas make sense with graphs, so this is just another way. Now, we're just going to kind of verify this. It says find the roots and the axis of symmetry for these simple factorable quadratic equations to see the relationship we developed in this exercise. So I'm actually going to find my axis of symmetry first. So axis of symmetry, negative b over 2a. So that's negative 5. So now I'm going to find the roots, and it says they're factorable, so these are easy factoring ones. I did that on purpose so we could find them quickly. So this factors into x plus 8, x plus 2, numbers that multiply to 16 and add up to 10. So when I solve it, I get negative 8 and negative 2. And when I look, right, negative 5 is right between negative 8 and negative 2. Averaging those two numbers, right, if I add them together and divide by 2, negative 8 plus negative 2 divided by 2, averaging gives me negative 5. The next one is just a Gcf factoring, so I take out my 4x, not 4x, sorry about that, just an x, right? We do not have a numerical Gcf, just a variable. So we take out the x, and we have 4x minus 5. So my one root is 0, and my one root is 5/4. Now this one's a little trickier to see. If I write this as 1.25, maybe we'll have a little bit better luck, but let's just try that axis of symmetry. I know I did this one in the opposite order. So negative b over 2a. So b is the negative 5, the number on x, so negative 5 over 2 times 4. So this gives me 5/8. Now, if I write this as a decimal, 0.625, okay, you're going to see that that's half of the 1.25. Or if I average my 0 and my 1.25 and divide by 2, if I take my roots and divide them by 2, I will get the 0.625, which is the axis of symmetry, which is the 5/8. So axis of symmetry is the average of the roots. It's right between the roots, and we also see that from those general solutions up here, right? Adding them together and finding their average in the quadratic formula.